Hey guys, let's continue our discussion on graphing circular functions. And we are now on the second function, which is cosine function. So our learning competency for this topic is simply we're going to graph cosine function showing the amplitude, period, and of course the phase shift. Let's have a recall from our standard form of equation for the cosine is simply y equals a cosine b quantity x plus c plus d. And what are its representations from the four variables? A stands for our amplitude. So again, when you say amplitude, this refers to our height from the center line to the peak, or simply from our highest point to the lowest point divided by 2. Okay, on the other hand, near B, okay, this is part of the period which has a formula of 2 pi over B. And of course, when you say period, it goes from one peak to the next. And of course, it could be copied and extended symmetrically. Okay, the next one, the variable here is C, refers to the phase shift. And this phase shift is referred to how far the function is shifted horizontally. It's either right or left from the usual position. And of course, the last variable here is D, meaning the vertical shift, meaning how far the function shifted vertically. It's either upward or downward from the usual position. Okay, so take a look on our diagram here, a period of your cosine function. Okay, so again, comparing with our sine function, in our sine function, it started on the origin, but this time on our cosine, it started on the highest or the maximum point. Okay, now let's have the graph of our y equals cosine x. Okay, so the same procedure in graphing sine. The first thing to consider is to identify your value of your a, b, c, and d. But on our example, y equals cosine x, it's simply that our value of a is simply 1 from the numerical coefficient. So our amplitude here is 1. And of course, our b is also 1. So from the formula of the period 2 pi over b, your b is 1. So simply 2 pi. So for y equals cosine x, one period of this is 2 pi. After considering the period, the next thing to consider is you need to divide 4 equal parts or intervals. Okay, so 2 pi divided by 2 at the middle, which is pi. Pi divided by 2 on this part is pi over 2. And on this interval, third interval, so pi over 2 plus pi is simply 3 pi over 2. So after you have known or identify your different intervals or 4 equal parts, the next thing to consider is to plot points showing first one is our maximum point. Or simply we have 0, 1, and of course we have 2 pi 1. Okay, so after the maximum point, okay, we have the minimum point, which is pi negative 1. Okay, and of course lastly we have the different intercepts starting from pi over 2, 0, and of course we have 3 pi over 2, 0. After you have plot the coordinates, okay, of our intervals, okay, we need to connect now and draw a smooth curve of our there you have it. So a smooth curve which has now a graph y equals cosine x. There you have it, guys, and this pattern could be extended, okay, either from left to right, considering your pattern, okay, which has a period of 2 pi. Okay, let's try another example. Okay, what if this time our example is y equals 5 cosine 1 half x. So our first step, first determine your terms a, b, c, and d. Now we have a is 5. 5 therefore is your amplitude. There you have it. And your b is 1 half. So from our formula for the period is 2 pi over b. Substitute of that 2 pi over 1 half. and applying our complex fraction, get the reciprocal of your denominator and proceed to multiplication. So reciprocal of 1 half is simply 2. So 2 pi times 2 is 4 pi. So again, for cos y equals 5 cosine 1 half x has a period of 4 pi. So there you have it. We are now ready to sketch the curve. So our one period again consists of 4 equal parts is simply 4 pi. Divide this one into 4, divided by 2, 2 pi, divided by 2, it's simply pi. So pi plus 2 pi on this interval is simply, we have 3 pi. Yes, there you have it. After considering now the 4 equal parts, okay, we have to plot our maximum point. Okay, and our maximum point is 0, 5, or we could have 4 pi 5. Okay, and of course, on the other hand, our minimum point is simply 2 pi negative 5. There you have it. And lastly, we have the intercepts. Considering, of course, this one, pi 0, and our third interval is 3 pi 0. After you have plot the coordinates, you are now ready to draw a smooth curve of this. So there you have it, guys. Our graph of 5 cosine 1 half x. You just copy the pattern such that your period is said to be 4 pi. Now, let's compare. Okay, considering our phase shift. Okay, compare this given function, y equals cosine x. Okay, then we have y equals 5 cosine 1 half x. Then y equals 5 cosine 1 half quantity x plus 1. On this third function, it has already a phase shift. Okay, and of course, we have 5 cosine 1 half quantity x plus 1 minus 3. It has already a vertical shift. So again, you notice here, this is x plus 1. That means it was shifted to the left, and this negative 3 shifted downward. Okay, now let us determine our graph of these 4 functions. Okay, with the 4 functions we have, okay, what will be the original diagram here? There you have it, y equals cosine x, our graph, and it was extended already, so it was copied from the first, or from one period, okay, from 2 pi. There you have it. Okay, one period, and another period is 4 pi, another period is 6 pi. Okay, now what if this time we have y equals 5 cosine 1 half x? There you have it. Okay, considering our one period, which is, yes, 4 pi is our one period. Okay, considering this time our maximum point is at 5, or our amplitude is 5. Okay, how about this time if it has what? A phase shift which is to the left. Okay, which is now y equals 5 cosine 1 half quantity x plus 1. So there you have it. It was shifted 1 unit, okay, to the left. Okay, what if this time shifted downward 3 units with this? So y equals 5 cosine 1 half quantity x plus 1 and negative 3. So again, from our highest amplitude 5, 3 units downward, 1, 2, 3. That's why it is at 2. The highest here is at 2. Okay, so there you have it, guys, the significance as we compare the different translations from the phase shift horizontally, and phase shift also from our vertical shift. Okay, and remember this, guys, as we compare the 4 functions here. And again, to sum up our discussion, as we generalize, okay, we generalize this time our discussion, which is bear in mind that when we are to show our graph of cosine, bear in mind the different terms again, from the amplitude, from the period, phase shift, the relationship of this to our graph. Okay, considering our steps in graphing the cosine function is simply what? We're going to determine your A, B, C, and D. Afterwards, okay, determine your value of your period, and with that period, divide it into 4 equal parts or 4 intervals. And with that, you are now ready to plot the coordinates starting from the maximum point, the minimum point, and then the intercepts. And then afterwards, you could now connect and sketch a smooth curve of that. And that would be now our pattern, as we would have a periodic function. It's just a matter of, as we extend it from left to right, you just copy that period. Okay, so again guys, hopefully you have learned something from our discussion, which is of course graphing function. And again, hoping and you will still listen and watch the next lesson on graphing of circular functions, which is on the third function. Okay, thank you guys.